Okay, so find the area of a shaded region. If you see the area of the circle here shaded, will be the big circle with a radius as a 1, 2, 3, 4, radius of 4 meter. But you can subtract the inside, the one wrap here with the radius as a 3. If you subtract that, then you will find the area around here. That's the first parts of this part here. And then second part of the circle will be the small circle here with the radius 2. And then you subtract the circle with the even smaller one with the radius 1. Subtract, then you can find the area of this one. So you add those two area and find it. So first we're going to go over with the circle area. So pi area circle area of the circle formula will be pi r square. So pi 4 square minus pi 3 square will give you 16 pi minus 9 pi, and then it will give you 7 pi. And then for that one's radius will be 2, so 2 square minus 1 square, so will give you 4 pi minus pi will be 3 pi. And you add it together because we need the shady parts of this one and this one, so you have to add both together. So 7 pi plus 3 pi together will give you 10 pi meter square. That's the area of the shaded part. And then find the area of the shaded region. For this one, we need to find the half of the circle area, semicircle, area of the semicircle. That's what we can find it here. Then we need to find the radius. To find the radius, when you see the right triangle here with the 10 and 24 as a length of 2 legs, we need to find the hypotenuse. So we're going to use a Pythagorean theorem. 10 square plus 24 square equal to c square. So 100 plus 576 will be c square, and 676 equal to c square, then c will be square root to 676, which makes 26. And the whole length of this one is 26. That means the radius r will be 13. So semicircle, area of the circle will be pi r square, but we need only half of that. So half of the pi 13 square will be 84.5 pi. I will express the exact, I will express as a 169 over 2 pi inch square. That's what I do. And then we can go to this one. Your dog is tethered to the center of the small wall of a 12 feet by 20 feet utility shed by a 20-foot leash, as shown in the diagram. To the nearest square foot, find the area in which the dog can play. So when you see the dog has a 20-foot leash and the length of this one is a 12 and 20, when you try to go from here to here, that's only 6 foot because half of the 12. And if it goes to as far as it can go, will be the total as a 20, right? So you can go 20 here, all around, which is a 20 foot as a radius. Half of the circle parts he can move around. And then if it goes to the other side, since he made a 6 6 foot here. Another parts it can go up to from here to here will be 14 feet because out of 20 feet, he used 6 feet to go to the end of the building. So he can go out of the building 14 feet away, and then he can go around with all the length to be a 14. So 1/4 of the circle with a radius of 14. And then it will be same here. He's going to move around until the radius of 14 with a 1/4 of the circle. So if you add this portion and that portion together, will give you half of the circle with the radius as a 14. With the blue one will be also half of the circle with the radius as a 20. So we're going to find those two parts of the area of circle and add it together. That's the area that which the dog can play. So half of the pi r squared plus half of the pi 14 squared. It will be half of the pi 400 plus half of the pi 196 will be 200 pi plus 98 pi will give you 298 pi feet square, but to the nearest square foot, so 298 pi will be approximately 936.195 feet to the nearest foot, 936 square foot. That's how you can say. And then this portion, the composite figure with below, the composite figure below has been constructed with 3 intersecting circles, each with a radius length of 1 meter. So from here to here, 1 meter. So if I draw triangles like this, triangles like this, triangles like this, each has the same length. It's equilateral triangle, and with this portion is 1. So if you are thinking about the equilateral triangle, will be one side length as 2 meter. Find the area and perimeter of the figure. So to find the area, when you see, you can see the parts of this half of the circle parts here, and then half of the circle parts here, and then half of the circle parts here. So you see 3 of the half of the circle parts plus equilateral triangle will be the total area. And then to find the perimeter, then you can see I just graph it here, and then here. Half of the circumference of each circle. So 3 over half circumference. If you add it together, then it will be a perimeter of the figure. So we're going to find the area first. To find the area of the equilateral triangle in the center, then 2 meter, if you draw height, it will be 1 meter here. Then 1 square plus 80 square equal to 2 square. So 1 plus 80 square equal to 4. And if you subtract 1, 80 square equal to 3, then take a square root, 80 will be square root of 3. So this 80 will be square root of 3. So area of the triangle will be 1/2 times base as a 1/4 side, which is 2, and height as a root of 3. So it will be root of 3 meter square. And then half of the circle will be, you have a 3 of half pi r, radius as a 1 square, will be 3 over 2 pi meter square. You add those together, will be 3 over 2 pi plus square root of 3 meter square, then approximately 6.45 0.44 meter square. That's how you find it. And then as you see the circumference, the perimeter, to find the perimeter, we can just find that the circumference, half of the circumference. So I will say it's still same method like this one. This is a area, and then perimeter will be 3 of half of the circumference, which is 2 pi r, radius as 1. That will give you 3 pi meter, and then approximately 9.425 meter will be circumference.